So very good morning students. Today we are continuing with the next video of big data subject. Today the topic of discussion is Hadoop Mapreduce. So first of all, what is Hadoop? Hadoop is an Apache top level project. It is an open source project implementation of framework for reliable, scalable, distributed computing and data storage. So we can say that this Hadoop project is available open source all over the network, and basically it is a project for distributed computing and data storage for large amount of data, that is called as big data. So it is a flexible and highly available architecture for large scale computation and data processing on a network of community or commodity hardware. So it can work on multiple type of input hardware as well as software. So first of all, I will go with the brief history of Hadoop. Hadoop is designed to answer basically the main question, that is how to process big data with reasonable cost and time. So there are two main important parameters. One is the cost parameter when we are processing the big data. Another is the time parameter when we are processing the big data. So if we are talking about normal data, then Hadoop is not required. But for large amount of data, say in the form of petabyte or zettabyte, we need a reasonable cost factor as well as time factor so that the results will be achieved within given time frame. So this is the developer's history. In 2005, Doug Cutting and Michael J. Kefrel developed Hadoop to support distribution for the Nudge search engine project. So this is Doug Cutting. He designed the Hadoop architecture in 2005. This project was funded by the Yahoo Corporation. So you can say Yahoo has first introduced the concept of Hadoop. In 2006, Hadoop gave the project to Apache Software Foundation. So Apache has taken over the project after 1 year from Yahoo. So nowadays Apache is maintaining from last 15 years the complete Hadoop frame set. So what is Hadoop? It is an open source software framework that support data intensive distributed application licensed under the Apache version 2 license. So Hadoop is licensed under this particular category of license. It is an open source license which is provided all around the globe. Now the goals and requirements of Hadoop. It is an abstract and facilitate the storage and processing of large or rapidly growing data set. It is a structured and non-structured data set. Simple programming models are used in it. It is highly scalable and available. It uses commodity hardware with little redundancy. It has fault tolerance feature. This is the main functionality of Hadoop which we'll discuss today. It moves computation rather than data. So simply it does not transfer the data from one location to another. It transfers the computation result from one group of clusters to another. The Mapreduce paradigm can be defined as it is a platform for reliable, scalable and parallel computing. So it abstracts issues of distributed and parallel environment from the programmer. It runs over distributed file system. There are two kinds of file system. One is Google file system, another is Hadoop file system. So HDFS and GFS, these are the two file system that are used under this Mapreduce paradigm. So it processes a lots of data. I will give you one statistics. In 2009, Google processed 24 petabytes of data per day. Nowadays, it can be up to more than 100 times per day Google process such large amount of data. So a single machine cannot serve all the data. So you need a distributed system to store and process the data in parallel. So you need some kind of parallel computing as well as distributed computing. So Hadoop paradigm works basically on this Mapreduce architecture. So how do you facilitate communication between nodes? This is a question which arises in parallel computing. How do you scale to the more machines, or how do you handle machine failures? These are the three limitations of parallel computing which can be overcome in distributed computing, that is your Hadoop Mapreduce paradigm. So the Mapreduce provides automatic parallelization, distribution, I/O scheduling, load balancing, network and data transfer optimization, fault tolerance, which includes handling of machine failure. It need more power, that is scale out, not up. So large number of commodity servers as opposed to some high-end specialized servers are needed in this Mapreduce paradigm. So it is basically a large amount of data pre-processing. So Apache Hadoop is an open source implementation of Mapreduce. So typical problems which are solved by Mapreduce are, it reads a lot of data, petabyte, zettabyte or more than that. So there are two main part, that is map and reduce, but two functional internal parts, those are called as shuffle and sort. So map extracts something you care about from each record, and reduce aggregate, summarize, filter or transform, and finally we write the result. So these are the problems which are solved by Mapreduce. Step 1, read the data. Step 2, mapping of the data. Then intermediate step, shuffling and sorting of the data depending upon the requirement of the clusters, and at last reducing of the data, which includes some inbuilt functions like aggregation, summation, filtration or transformation, and finally writing the result. So Mapreduce workflow can be explained with this example. Say we have this input data which is split into 3 parts. Now we assign 3 different workers, means we mapped the split 0, split 1, split 2 with different worker. It extracts something you care about from each record. Then you locally write these record and reduce the workflow from 3 to 2. Here 3 map functions are done, but finally on the local machines or different cluster, it is reduced to 2 workers. So means 2 machines are working on it and they finally giving the output data. So within this part there is a shuffle and sort function. So one is map function, then sorting, shuffling, remote reading, all these are the intermediate functions which are performed on local machines, and at last in the reduce phase the data is reduced. Here the aggregation, summation, filtration functions are applied and the result is written in the form of output file. So this is Mapreduce workflow. So the mappers and reducers which are used to handle the data, they can handle more amount of data, more size of data, no need to handle multi-threaded code. This is the advantage of mapper and reducer architecture, you can say Mapreduce paradigm. No multiple threading codes are required to handle. So mapper and reducer are typically single threaded and deterministic applications. They allow for restarting of failed object. So if a project gets fail in between the execution, because it is a distributed computing, so it can be restarted. Mapper reducers run entirely independent of each other. They do not get dependencies. Few clusters are running the map function, another few clusters are running the reduce function. So in Hadoop, they all run in the Java virtual machine. Separate JVMs are enabled on different machine. The JVM is a component of Java runtime environment, which is nowadays available in all of the softwares, whether operating system software or system software. So we are taking one more example of Mapreduce paradigm. So say the problem is to count the unique words in a given statement. So I have given 2 files. One is opal, apple, orange, mango, orange, grapes, plum. Few 6 words are written here. Another is apple, plum, mango, apple, apple, plum. So now these are the 2 input files and I want to get output in a single reduced format, that is single one output file. So the very first step is the mapping function, the mapping with the key value pair. First I will store the values, then I will make its keys accordingly. So the map function contain key value pairing or key value splitting. So first of all, there are 2 lines here. So I have split this complete input file into 2 subfiles. First contain apple, orange, mango. Second contain orange, grapes, plum. Similarly, the second file also has 2 lines. I have split it into 2 separate lines. Similarly, you have to decide how many number of subfiles can be generated from a given single input file. Now, after this is the main part, that is the mapping part. So here apple occurs 1. So I have written apple 1, then orange 1 time, mango 1 time. Here orange 1 time, grapes, plum. In the third part, apple, plum, mango, and apple, apple, plum. First, I have written their unique individual entity. This is the mapping first mapping function is splitting the value with the key. So 3 different keys are generated here. Now the intermediate part, shuffle and sort. This part combines the same type of data from different files into a single separate file. Like all apple entries come into a single file, all grape entries come into a single file, mango entries come into a single file, orange or plum entries come into separate file. Now these are the sorting and shuffling depending upon the result required, because we have the problem given here is to count the words. So I have to apply sort and shuffle function accordingly. Now the last step of Mapreduce paradigm is reduce. So apple occurs 4 times. So I reduce the value to 1 apple, but key is increased to 4. So apple is 4 times, grapes is 1 time, mango is 2 times, orange is 2 times, plum is 3 times. So in this way, Mapreduce paradigm maps, shuffle, sorts and reduce the key value pair, and we get the final output in the form of 4 apple, 1 grape, 2 mango, 2 orange and 3 plum. So this is an example of Mapreduce paradigm for the problem word count. So now in the form of commands it is written here. So say input file needs a pair value, that is key and value. Output is in the form of KV. So let's count number of each word in unique user query. Like today, nowadays, so many tweets are going on, hashtags are there, various blogs are written, keywords are written. So the input to the mapper will be query ID and text ID. So here I have taken one more example. The teacher went to the store was closed, the store opens in the morning, the store opens at 9 AM. So this is the input key value pair. So I have split it into different. Key is something different, value and different. Like the comes 1 time. Here capital T is there and small t is there. So both are treated as separate entities. So first the single occurrence of come here. Then after that the reducer function now combine all of them. As like in the previous example, here store word came 3 times. So store has the value, key value as 3. Similarly, the word came 6 times. 1, 2, 3, 4, 5 and 6. So 6 times this came. So the has value 6. This is the 6 THE command. So went, close, open, morning. So this is the reduce function. So I will show you once again for the given problem statement, that is again of word count problem. So this is the given mapper function which maps it accordingly, and this is the given reducer function which reduce it accordingly. So this is again the pictorial representation which I have shown you in the previous diagram. So given input data is split into 3 parts. First the worker is assigned, then this is the master cluster. I will show you the main part. The master cluster is called as the HDFS name node, because the Hadoop Mapreduce contain different file system that is called as HDFS, Hadoop distributed file system. So this is the master computer system which is called as a name node, where the results are computed and the output is given. They are the output data directories. So split operation is performed, split 0, split 1, split 2. 3 split operations are there. Then the reduce and assign functions are also there. So this is the Mapreduce framework. So it works in collaboration with Hadoop distributed file system. So these are the 2 main important components of Hadoop Apache Hadoop project. One is the HDFS Hadoop distributed file system. Another is Mapreduce paradigm. So on the basis of this Mapreduce and HDFS, complete distributed base processing is executed. It split the data and thus store 3 replica on commodity server. So this is our HDFS 1, 2, 3, 4, 5. It is split into 3 replica. 2, 4, 5 come here, 1, 2, 5 come here, 1, 3, 4 come here, 2, 3, 4 come here, 1, 3, 5 come here. So every item came 3 times and a combination of 3 replicas are created here. So this is the way how Hadoop distributed file system works. So now the most important part and the last part of Hadoop project is fault tolerance. So there is a master scheduling policy, like there is one Google file system. The Google file system for location for replica of input files blocks all the master scheduling policy, map task scheduled. So GFS input block replica are on the same machine or the same rack. So in GFS or Google file system, maybe the different input blocks are on the same file. So there can be fact that either we need thousands of machine to read input data at the local disk speed, and it eliminates network bottleneck. So one requirement is that you maintain thousands of machines together, they utilize their computing power and no network delay or network failure is there. Another way is the failure. How MapReduce handles the failure? As failures are normal in commodity hardware like networking hardware, failure can be detected via periodic heartbeats or re-executing progress and MapReduce task. So maybe there can be a master failure, or you can say single point of failure. So if the centralized system goes down, then it is called as a master failure, but we resume from the execution log from the back commands like commit or rollback commands are used to handle this master failure. Google's experience is that it is an example. Google lost 1600 to 1800 machine together at one time, but they finished it fine. So it is all because of the robust architecture of MapReduce. If the worker gets failure, then task completion committed through the master. So if master gets failure, then rollback or robust experience of Google file system can be utilized. So both kind of failures can be handled. So how to refine it? Slow workers significantly lengthen completion time, like the system which have little slow computing power, they increase the overall computing time. So other jobs consuming resources on the machine, it can be the one of the reason. Then bad disk, like your hardware, disk storage where data is stored, they transfer data with very slow speed, or some weird things like cache disabled. Sometimes in the browsers cache is disabled. So every time you open the application, it starts from the scratch. So the solution is spawn back the copies of task. Means the task has been performed, make a copy of it on the backend server, and if a failure occurs at the worker side, then you can call that copy once again. Or the bad record problem can be handled like we can skip the bad record. Bad records are like bad sectors or bad failures in the system. MapReduce functions sometimes fail for particular input. So in that case, best solution is to debug and fix. But it is not always possible to debug all the errors and fix them. In that case, you have to skip the record. So this is the only option, skipping the bad record. If there is a bad record, you can skip it. So these are the few references which I have taken to prepare for this lecture. So there are two books, Jeffrey Dean and Sanjay Ghemawat, MapReduce Simplified Data Processing on Large Cluster. You can get the particular MapReduce architecture from this book on the given link here as well. One another book which contains the information about the Google file system, that is consisted here, the lab Google file system. So thank you very much, students. This is the lecture for Mapreduce Paradigm. So we'll continue with the next topic in the next class. Thank you.